Students, welcome back to our YouTube channel. I am Teacher Martin, and today we're going to look at a question from linear motion, and that question is based on vertical projection. The question reads, a stone is projected vertically upwards with a velocity of 30 meters per second from the ground. Calculate A is the time it takes to attain the maximum height, the time of flight, the maximum height reached, and the velocity with which it lands on the ground. Now, before I give you the solution to this question, I'm going to explain a few things. When we have the vertical projection, we have three main equations that we're going to use, and those equations they are followed by vertical projection when the body is moving up or when the body is coming down. Now, when the body moves vertically upwards, it attains a maximum height, and at that maximum height the final velocity is 0 because the body appears to be standing, so the body is at rest at maximum height. And also we have the time of flight. Now the time of flight, the first one is the time it takes to attain the maximum height, so it is the time of projection from the ground to the maximum height. However, that piece of stone is going to come down. Now the time it takes to come down from that maximum height plus the time it was used to rise, the total is the time of flight. And also we have the maximum height reached. I've already explained that, and the velocity with which it lands on the ground. Now we are going to solve the first one, is the time it takes to attain the maximum height. We use this equation, the first equation of vertical projection, that is V is equals to U minus GT. Remember, V is the final velocity, U is the initial velocity, G is the acceleration due to gravity, and T is the time taken. So we have the final velocity as 0. We are going to rearrange this equation, and we'll be having negative U is equals to negative GT. The negative cancels out, and because we are looking for time will be given by U divided by G. So U is the initial velocity, which is 30 meters per second, and the G is the acceleration due to gravity. In this case, we have been given 10 meters per second square, so there is an error here. It's supposed to be 10 meters per second square. In some cases, you might be given acceleration due to gravity to be 9.8 meters per second square. When you are not given the acceleration due to gravity for bodies moving vertically upwards and downwards, you use the 9.8, but because we have been given 10 meters per second square, this is the one we are going to use in this question. So the time it takes to reach the maximum height is 30, which is the initial velocity, divided by 10, which is acceleration due to gravity, and you get 3 seconds. So the second part of the question is the time of flight. As I said earlier, the time of flight is the time it takes to reach the maximum height and come back. So it is the time it's used to attain the maximum height times 2. So we add just 2 behind this equation, so we'll be having the time of flight as 2U divided by G. So 2 times 30, that is 30 meters per second. That is the initial velocity divided by 10, and you get 6 seconds. So 6 seconds is the time of flight. As you can see from these values, the time it takes to reach the maximum height is the same time it returns to the ground. So in other words, you can get the time of flight as is twice the time the body takes to reach the maximum height. So the third part of the question is the maximum height reached. In this case, we are going to use the third equation of vertical projection, which states that V square is equals to U square minus 2GS. And in this case, we just replace S with H, because S is displacement and H is also the height, so it's a displacement. We have the final velocity as 0, because when it reaches the maximum height, the body becomes at rest, so the stone will be at rest. We rearrange this equation, we will be having U square is equals to 2GS, and remember s we have replaced it with h. So if we make h the subject, we get h is equals to u square divided by 2g. Now u square is the initial velocity square, that is 30 meters per second square. You get 900 meters square per second square. We divide by 2 times 10 meters per second square, and you get 45 meters. So 45 meters is the maximum height reached. Also, we are going to look at the fourth part of the question, which is the velocity with which it lands on the ground. Now when the stone moves upwards, remember when it moves upwards, it reaches at the maximum height where it appears to be at rest, then it comes back. Now as it comes back, it increases the speed, and its speed is, we obtain that speed using this formula. Remember, when it goes up and comes down, there is no displacement. So displacement in this case is 0, because it has returned to the initial position, meaning the displacement is 0. Now 0 will affect the whole of this, so we'll be having the total of this to be 0. And now v square, because v will be having a value, will be equal to u square. U square is 30 meters per second square, which is 900 meters per second square, meters square per second square. And if we get the square root of u square, we get 30 meters per second. This means that the stone will land on the ground with the same speed, with the same initial speed, meaning initial speed will be equal to the final speed. Thank you for your participation in this video. Make sure you like, subscribe, and also comment, and also make sure you go back and watch the videos that I have uploaded earlier, so that we'll be moving together.